folks, welcome back. So let's take a look at this next example, example 3. And if I look, I've got my two fractions. And again, I'm being asked to add those fractions. And the fortunate thing here is these fractions already have common denominators. When you get to a point where fractions have common denominators, your life becomes a lot simpler. So what I'm going to do is I'm going to keep this common denominator. I'm going to put the equal sign here. And I'm going to keep it as x plus 5, x minus 2. And then I'm just going to add the numerators together and see if I can find any like terms. So let's go ahead and take a look at that. So I'm looking at x squared plus 3x minus 2. And then I've got a 4x plus 12. Now something I mentioned back on example 2, just to kind of preview, if this had been a subtraction sign, and it's not, but if it had been, I would have had to distribute that subtraction sign, like if this was a minus, I would have had to distribute the minus to the 4x and the 12. So I just want to kind of give you a preview of what's to come, that we want to be careful when we have subtraction, and we're actually going to see that in the next example. All right, so once I do all of this, it's just a matter of collecting like terms. So as I go through this, I've got an x squared. I don't see any other x squareds. I see a linear term with 3x and 4x. And then I see constants with -2 and positive 12. So those are the terms that I can combine. So if I start to break this down, what do we have here? We have x squared. All right, 3x and 4x is 7x. -2 plus 12 is 10. And then I've got this over x, plus 5, x minus 2. All right, and so we're cruising along here, and this is going to add, this problem adds another component to these types of problems, in that x squared plus 7x plus 10 is a quadratic that can be factored. So we think of numbers that multiply to 10 but add to 7. So if I'm taking a look at this, right, two numbers that multiply to 10 but add to 7 are x plus 5 and x plus 2. Right? And then I have this over x plus 5 and x minus 2. All right, and so then you can kind of start to see that there's a factor common to the numerator and denominator, so those are going to divide out or cancel out, and that ultimately leaves me with x plus 2 over x minus 2. And things that I've seen in my teaching days, I see sometimes students want to cancel this out. They'll say, oh, this is x over x and 2 over -2. You can't cancel in that manner. So you've got a binomial down here. You can't just cancel monomial to monomial, monomial to monomial. It would have to be binomial to binomial, and since these are not the same expression, x plus 2 is not the same as x minus 2, this is just as far as we can go. So this is the end of the line for that problem. All right, thanks so much. Bye.